XCharge reached out to us and said, hey, we have this really cool battery integrated DC charger.
Then we'll have our DC positive and negative that tie in, that give our DC power to our dispenser.
And very much excited to get our XCharge NACS cable on this bad boy. So.
Woohoo! Well, congratulations on not dying.
Yeah.
Found it. Hell yeah. We're going to flip the breaker on. Austin, you have the pleasure of doing it. First time in really ever, we're turning the battery on this unit. Thank you to our sponsors for today's video: InfyPower, Amber, StarCharge, and Nokian Tyres. InfyPower is the largest EV charger module provider with over 3 million power modules running reliably worldwide. Their latest G2 collection features ultra-high power density and efficiency for EV charging and energy storage integration. InfyPower, innovation for your power. Amber offers a modern extended warranty for your Tesla's battery and more without the burden of long-term contracts or upfront payments. Check out the link in the description below to browse their plan options and get started with a free over-the-air diagnostic check. This video is also brought to you by StarCharge, the largest EV charging manufacturer in the world, and is also a provider of residential and commercial battery storage as well as microgrid solutions. And Nokian Tyres, a leader in safety and sustainability. Maximize performance and efficiency with their made in USA all-season tires and their dedicated Hakkapeliitta EV winter line from the inventor of the winter tire. Learn more at nokiantires.com/EV. Hello and welcome to another Out of Spec Reviews video. Welcome here to our office and welcome to our new DC fast charger. In this video, I'm going to walk you through the entire installation and boot up process of our brand new XCharge Net Zero series. This is not just a DC charger, it's actually a DC charger with a battery integrated unit right over here, which means we have over 200 kilowatt hours of integrated battery capacity. And what's really cool with this is rather than running a dedicated line, big power, upgrade our transformer, we're actually able to replace a level 2 charging station with DC fast charging. Now, there are so many applications that this type of technology can be useful for. Not every situation. So I first want to walk through where you might want to install a charger like this, what this charger is really great for, especially rural communities, situations like how we're using it. And then, of course, I'm going to walk you through the very convoluted installation process, because installing charging is not that easy. And this is about as easy as it gets. Well, guys, you can see the DC charger is active. And if you just hang on towards the end of this video, you'll see our first ever charge. And then we'll have another video coming soon where we're going to absolutely stress test it. I don't want to focus too much on the actual finished product right now because this video is all about the installation process. And so I want to thank a few companies for really partnering with us and helping us to learn about DC charging, installing them, and of course, it all starts here with XCharge. XCharge reached out to us and said, hey, we have this really cool battery integrated DC charger. And we posted a video of us unboxing this unit. And they sent this to us as sort of a long-term test, a long-term review unit. And so I can't thank XCharge enough for letting us have this charger, use it, play around with it, learn about charging. And man, it's so cool. I also want to thank Winn Marion. Winn Marion is a really important partner to us in this installation. They're the guys who actually did all the wiring. So they, our office building put all these like EV signs, EV parking only. Everyone's worried about gas cars parking here. I think they look really ugly. I'm going to take them off and we're going to wrap the charger in a future episode. But Winn Marion, so cool. They did all the wiring. They handled all the permitting process. They handled the installation, the physical installation, as well as the wiring. And a big shout out to Winn Marion. They ran the lines all the way here, which go into the building. We'll show everyone that here in this video. Winn Marion's going to be a huge part of this video. So between Winn Marion and XCharge, we had a really good combination to get this charger in the ground. That's not to say it was easy or fast or was painless. I'm going to walk you through a lot of that pain and suffering over the last many months waiting for us to install this big boy. And then, then we'll start and go through the whole construction process. Let's do it. Now, it's many minutes later, but I just wanted to touch on everything that happened pre-construction of the DC fast charger. This episode is, of course, about installing it physically, but before we installed it physically, there was a lot of work that needed to be done ahead of time, and that was our permitting process. And originally, we thought we would just submit a permit a week or two later, we'd be good to go. But between the, Winn Marion also, as part of their services, not only do they install DC fast chargers, and Winn Marion installs many DC fast chargers in the Colorado area. I think they just did a huge bus terminal in Aspen with like pantograph charging and a few other things. They're doing some really cool work. And maybe we'll be able to highlight some of their like awesome charging install sites. This is a pretty basic one for these guys. They're like, oh yeah, let's just roll. I did just, they had to go through the permitting process. And so we asked them to handle that for us, and they were happy to. And man, did that not go as expected. Many of you will know we're like, we're going to get the charging installed soon. And then months and months and months have gone by. Over 6 months from when we first received this charger delivered. And that is really just all permitting held us up there. Some of it was, okay, at least at the beginning, okay, Winn Marion, it wasn't their fault. I sent an email too late. I held up the process a bit at the beginning. That's very typical for me. And then Winn Marion, once they got all the info they needed from our side, just pushed and pushed and pushed. And the city of Fort Collins pushed and pushed and pushed in the other direction. And, from my perspective, the city of Fort Collins is supposed to be a green, EV-friendly place, and it's actually not a great place to install DC fast charging. Not only do we have a terrible rate structure from our local cooperative, our local city's power system, we don't have the choice to choose who we buy our electricity from. We are forced to buy it from our, sort of city's utility. And because of that, they set the rates, and there's no way around it. And the rates are astronomical for DC fast charging because, of course, with most commercial installations, you're not really concerned about the energy content. You don't care about what the per kilowatt hour cost is. It could be 3 cents, 5 cents per kilowatt hour. That doesn't matter. It's all about the demand charge. And with DC charging, you get a huge demand charge typically. And so if we were to put in a 400 kilowatt charger and only use it once, that single charging session could be tens of thousands of dollars with our current rate structure. So I thought, okay, well, the only way to make money with DC charging is with high utilization. You either put in low power DC charging, which is currently what we have in our city right now. We're the third largest city in Colorado, and the highest power DC charger installed is 62 kilowatts. We have an insane adoption rate of electric vehicles. And the fastest charger we have here is a 62 kilowatt charger, and it's at a GMC dealer. The next fastest would be 50 kilowatt EV Goes. That's unacceptable. That's crazy. But because of the city's utility rate structure, this is why. I'll get back to that in a moment. The second issue with permitting, or with our city, was the permitting process. We're supposed to be a clean, green, friendly city. Maybe there was a way to expedite permitting or something, but that was really a pain. And I wasn't super involved with the nitty-gritty details. Perhaps we can even do a podcast with XCharge and Winn Marion about the permitting troubles of this particular project. But because our office is on a historical site, because we had some other things going on, I couldn't remember exactly. It just was months of back and forth and back and forth and back and forth. And you'll notice the charger is installed in not the best location. Ideally, we wanted it where the shrubbery was, but then that was going to add months of permitting just to make sure the landscaping things were going to look great. So we're like, just throw it in the parking spot. It's long enough. It's approved. Let's get it installed. So the city of Fort Collins, again, claims to be clean and green. I'd love to help them achieve that mission. 7 months to install a DC charger where there was already an existing level 2 station is not clean and green. That's crazy to me. And this whole process was insane. So again, I just have to say, before we even installed the charger, just the paperwork and approval process was insane. And this was best case scenario. This is taking an existing level 2 station, upgrading it to a DC fast charger, and that was months and months of delay in permitting. I don't know how we're ever going to be able to build out a comprehensive DC fast charging network if this is the experience replicated everywhere. And what I've heard is Fort Collins isn't even the worst of many cities in Colorado. I've heard through some friends and also through some contractors that there were many DC fast charging projects in this state canceled because of the permitting delays, years, even worse than the utilities at times. The second thing, just to go back to our utility rate structure in the city, we now have the highest power charger in all of Fort Collins, and we're only able to do that at a reasonable cost because of the battery integration of this XCharge unit. At most, we're ever pulling maximum 19 kilowatts from the grid, but we can dispense 170 kilowatts or 169 kilowatts in our case. And so really, if we had to pay the demand charge of 170 kilowatts, it would be through the roof. And we are going to have to do that. I want to install dedicated high power charging. We have some going in, and I'm going to have to eat that cost every month. But it's really not practical. We can, of course, monetize that by charge testing and making videos for you guys, and that's awesome. And whether or not we'll even make back our money, I don't know. Probably not. But at least we're doing something cool and interesting in testing, and that's what this is all about for that particular portion. This charger really makes economical sense because it can just slow charge when it's not in use and then dump the energy into a vehicle when it's needed. And so therefore we now have the highest power charger in all of the city, which is crazy to me. Okay, that's enough talking about the everything that happened before we installed this charger, the considerations, why we're so thankful to XCharge for letting us try out their battery integrated unit, and why this is the perfect use case for this particular charger. Look, I'm the first one to argue if you're going to do off-highway charging and you're going to have huge throughput and you're going to do a big DC charging park, you want dedicated power to just rip juice. That's where you start putting in dedicated grid connected power. But if you're in a infrequent use area or a rural area, so a charger that's only going to be used a few times a day rather than a few times per hour, then yes, this battery integration makes all the sense in the world. Okay, back to the video. Oh, guys, one quick thing before we get into the whole setup process of doing this charger, I just want to walk you through what it is. So we have in this video, you'll see we've swapped on a NACS and CCS cable. So it was originally dual CCS. When we unboxed it, I wanted to have the J3400 North American charging standard available for us at day one, at launch. That was really important to me. But this charger essentially only has a 19 kilowatt grid connection. We have just a very low power. Some of their newer units can actually take 208 volts, but we ran 480 out here because we wanted to get as much power as possible. And we're replacing essentially a 12 kilowatt level 2 station. It was dual 6 kilowatt ports that had been here forever. So we thankfully had a 480 panel right next to our 208. And so now we're running 3-phase 480 right out to here. You'll see all that in the video, which means we only have 19 kilowatts coming from the grid. This is a perfect solution for folks that have high demand charges or that are in areas that literally cannot get the power. One of the biggest holdups to DC fast charging is power availability. If you look at commercial sites that are wanting to switch to electric, medium, and heavy duty trucks as an example, just getting the power from the utility is number one issue across the board. And so a solution like this, where you don't really need that much of a power upgrade or no power upgrade at all, can then dispense up to 200 plus kilowatts. This station is capable of over 200 kilowatt dispensing if you had a bit more of a grid connection. The battery pack itself can output 150 kilowatts. And then you have to supplement that 150 kilowatt output from the battery with whatever you get from the grid. In our case, 19 kilowatts, which means we get 169 kilowatt charging. And you'll see us try that out, and that works great. No issues doing that. I'm filming this about 2 weeks after installation. I've been ripping EV6s, Lucids, everything on here at 169 kilowatts. Love it. And yeah, so that's pretty cool. We'll run through in the future, sort of looking at the battery pack, learning about usage, looking at where people charge, how high do I charge the battery. Right now, I have it set to charge not past 90% state of charge, but if people use it more, I may need it to go to 100. So far, it's been full charging overnight, and so everyone can start the day with a fresh charged battery in this thing, but these are the things we'll be learning over time. So join me as we go into our XCharge long-term review series, and it all starts by getting this thing in the ground where you see it right now. So let's go meet with the guys from Winn Marion. You're going to see Colton and Alyssa. I wasn't actually here for most of the installation. I was here for the last couple days. And so, yeah, let's go install this thing and see what it takes to install a DC charger.
Hey guys, it's Colton here, and we're at the CSU Powerhouse. Kyle just called me. I was just working at the shop today, and he said, dude, you got to run over to the office here. We are getting our DC fast chargers installed. So they have pulled these out front here, and we're going to get the guys on camera, just talk to them a little bit about what's going on. I've talked to all three of these guys quickly. They said this is a new install for them. They've of course never worked with these units, so they're trying to make sure everything's done right the first time, just taking their time with it to make sure it's really done right. So that is absolutely awesome. I'm going to try and stay out of their way, but I'm going to try and get a few of them on camera here, just talk about what they're going through, how this is all going to work. This is really not my area of expertise, of course, but Kyle just wanted me to come get some clips for you guys. So hopefully I can do that. And yeah, what an exciting day here.
Into the charger or to the battery bank. But this to me.
All right, guys, I'm here with Josh, and Josh is going to run us through basically the whole install here. So thanks for being on camera with us first off, and then thanks for installing this because we're super excited for it.
You're welcome. My name's Josh Cole. I'm with Winn Marion, and we're going to work you through a XCharge install. So we're just trying to get the basic layout here, making sure all our NEC required clearances are met for inspection. But basically for the one line walkthrough, we're going to be coming out of this 1-inch pipe with 3 brown, orange, yellow 480 conductors with a neutral and a ground, number 10 ground, and 4 number 6 conductors. We'll be coming out of that to a disconnect with a 50 amp fuse. This will be have a 50 amp circuit breaker that feeds it. That's going to be our circuit protection. So from that disconnect, we will tie directly into our dispenser. The 480 goes into this dispenser. From the dispenser, everything is going to loop through with DC power, a positive and negative cable, along with some communication wires and a Cat6 communication to our battery bank, which they call a CSS, I believe. Those two will be side by side on this base, and that's why we're trying to get our clearances. They have some doors that open, and we need to make sure we have adequate clearance for maintenance and things like that. Once we get those set, we'll be able to tie into our transformer, our 480 power that trickle charges the battery bank. That also will feed 277, a hot and a neutral, out of the 480 panel into our transformer, and that's going to convert to a 220 volt line and neutral, or basically 2 hots that will feed the HVAC system, which is the cooling and possibly heating of the battery bank. Depending on the outside temperature, we'll need to keep those batteries at a certain temperature, and the HVAC system will do that, and that's our power source for that system. That system obviously won't run off a 480 or 277 volt, so it'll need to be converted into a 220 volt system to power that, and that's what this unit is here for. So we're going to set it in the back, make sure we have adequate clearance, and tie it into this base with line in from the dispenser, which will bring 277 in, and then 220 out into the battery bank. Other than that, we're just getting our layout set up. Once we get our layout, we're going to mount our base down, we're going to mount our transformer down, and we're going to mount our strut rack for our disconnect and start setting the dispenser in place and set the battery bank in place. And then we're going to start tying everything together, and you'll see that in the next video.
That's awesome. So Josh, just run me through roughly, because Kyle had talked me through kind of where this is going. I don't know if plans have changed. So is everything basically taking up these 2 parking spots here, or?
Everything's just going to take up this 1 parking spot. So the full level 3 system will be on this base that you see here. And all you'll have is the transformer and the disconnect behind it. We need adequate access for the disconnect. So the dispenser will take up this whole width of this space.
Wow.
And even though this level 3 is nice because you don't have to have the amount of amperage and power from the panel that you normally would, and the amount of size feeders that you would need to feed this, to have immediate level 3 charging from this dispenser, it does take up a lot of space. And that's because of the battery bank. And that battery bank allows you to trickle charge with a much smaller feeder and much less capacity from your panel. And it will charge that battery bank, and that battery bank will hold all your DC power for your level 3 charging in the battery bank and give you instant level 3 charging through that battery bank. But it does take up a lot of space. So there's benefits and drawbacks to that.
Sure.
You know, if you don't have the power capacity, where normally you would have to have a service upgrade for your panel and larger amperage capacity for a smaller level 3 that's the size of the dispenser. If you don't have that, then this is your option for that, but you need the space for it. Obviously, it's going to take up about 6 feet of depth because of your transformer and your disconnect, but it's also going to take up, I think this was 94 to 96 inches, which is about 9 feet, which is your average space width of your space. So you lose a little bit on space. Luckily here we have a nice deep space for parking, so we can take up this amount of space and still be able to pull in a Lightning, which is a pretty long EV truck. Our other option would have been to clear out this vegetation and put in concrete. I know in this situation they wanted to avoid that because of permitting issues. You get into a lot of landscaping reviews, site plan reviews. It adds a lot to the permitting, and this one already took multiple months to get approved without those changes. So luckily we had the space of the parking, and we were able to have the space for the charging equipment, so it all worked out.
Very cool.
We're just going to work out the spacing and make sure everything's adequate, and we'll start the install.
Sweet. And kind of want to look over here at the battery bank and the dispenser, if you can kind of run the viewers through quickly, kind of how these hook up and just some more, I guess, info on them, because I think this is a pretty exciting day for us, and I know the viewers have been waiting forever to see all of these.
Well, I'm excited because Winn Marion, we install for ABB and we sell ABB chargers, but we obviously do charge point, juice box. Now we're doing XCharge. This will be our first XCharge unit, so we get to learn how this one's installed. This is going to be our battery bank. If the other side was open, you'd actually be able to see all the different power modules, is what we call our battery banks in here. And as you can see, this is where all our input power is going to come in, our main circuit breakers. We're going to be tying in our power from our transformer into this customer auxiliary power, and that's going to power our HVAC system to heat and cool this unit. Then we'll have our DC positive and negative that tie in, that give our DC power to our dispenser. And then we have some Cat 5 or Cat 6 and auxiliary controls to just communicate between the battery bank and our dispenser. And if we walk over here to our dispenser, you've got the front of the unit, which is a classic level 3 dispensing unit. You've got dual CCS cables. readout screen with controls. And then around the back, you have this unit can be run, I believe, with power modules on its own and have a single standalone system. But that's when you need your 200 amp, 300 amps of power from your panel with large feeders, possibly 500 MCMs, at least 350s, possibly even parallels, to run out here from the panel to power these. And you'd have your power modules or battery banks within this, in these slots, and you'd have all your internal power in here. You wouldn't have the separate battery bank. Now with the trickle charge, with the smaller feeders, you have the separate battery bank, and we're going to tie those together. But if you come and look on this left side of the unit, that's where our input power is going to come into. That's your line 1, 2, and 3, and your neutral 480 power. And then if you look on this right side, you have your Cat 6 communications between the units, your control cables within the units that communicate back and forth, probably e-stop. You also have your, your door open sensor to make sure your door's opened or not opened while charging is being initiated. And then you have your power, that's your 277. That's going to power the transformer. It's going to feed off of this 480, but it's going to supply input power to your transformer to convert to 220 to power your HVAC system on the battery bank. And then the last part of it is the DC positive and negative, your red and blue, that actually gives you your battery power from your batteries for your level 3 charging.
Very cool. Thanks for walking us through this. And I know, so next steps, we're gonna, I guess you kind of got to get stuff moved over there, you said, and then start wiring up everything. I'm so excited for this. This is pretty awesome.
Yeah, me too.
Cool. Thanks so much. Appreciate your time.
Good morning, guys. It is now Monday, a day before we hopefully go through commissioning, and I am back in town, able to check out the progress of the installation, and things are going well. We have a cable run from over there, from basically our junction box to the output line right here, and this will be basically feeding the cable today. So today is wiring up everything, and we will have a maximum 50 amps of 480, which is just over 20 kilowatts that we can pull. But of course, we have to run it at 80% maximum. So we really will have about a 20 kilowatt input feed that will just be feeding this charger all the time, flat out, nonstop. Hopefully overnight, that's enough to charge up the battery. And then we will, you know, of course, drain it during the day. So it'll be interesting to see how it works. And then we might, at the future, want to add a second battery pack if we're draining it. So they're working on the lines right now, making sure we get suction. We're on the same lines, pulling a bag through. And yeah, it's wiring day. Should be cool. With the clouds coming in, you now join me a few hours later. And holy smokes, Alyssa, this place is getting tore up. Not only are we installing a DC charger, but of course we ripped out a level 2 to put here. We're putting another level 2 here with an upgraded Autel dual 80 amp output. Now we have a power restriction as to as much power as we can get through the line here, but it should be awesome. So we're doing some boring underneath this way so that we can basically get the copper to the level 2 charger. But the main purpose of this clip right now, and I shot over here to the office to really decide how do we protect the XCharge unit. Of course, this is an expensive unit. It could be potentially dangerous with high power if someone comes ramming into it. So as per code, and really for my own ability to sleep at night, I want to protect this charger with bollards. And so we need to talk about where to put bollards. And so many times you and I as EV drivers have run into issues where they're in the least convenient place for cable access. But then there's also code requirements as to where they need to be, and we need proper protection. So my main concern really with all the bollards are nothing really around this way or over there. That should all work just fine. Of course, I want to get as close to the unit as possible while remaining safe, so that if we need a long cable reach, you can get the vehicle in the best possible place. But my main issue is this area right here, and the main concern is, will we have enough room to get the cable out and around? And the answer, looking at right here, is yes. There is plenty of access space to pull this cable and to basically interface it with a vehicle regardless of where the charge port location is. But just to simulate everything, I'm gonna pull Tyman's Model 3 over here and simulate a very popular vehicle that we're gonna test, which is a Model 3. It's so loud over here because they're doing boring as well. So let's pull the car over and make sure that these Bollard locations are good before we start to drill them in. Well, you join me in Tyman's Model 3 at the moment, and we are just going to double check the bollards are in a good place. So let's head over and talk to the Winn Marion guys about a proper place to put the bollards. And I think a lot of Tesla owners are probably going to nose in with the charge port in the back left. So I'm going to try both vehicle configurations and arrangements just to make sure everything fits and we're all good. So I'm coming up here. That feels about as forward as I really would want to go. We'll open the door. And we have some, yeah, I can get to 2 clicks. That feels pretty good. Into park, let's take a look here. Oh yeah, okay. Now keep in mind the Cybertruck's gonna be a bit bigger, but let's look to see how much room we have on this side. Oh, still plenty. I could come over farther to the right and have room to open the door. Can we see if the cable will reach back to here? It should, I think. So as long as we don't knock anything over. Yeah, there we go. Oh, all day long. Easy. Look at that reach right there. Okay, that's awesome. And then I think we have to, yeah, there you go. Release it in. Pulls it up. I'll hand that back to you. So that works pretty well. I'm going to back in, make sure we're good in terms of getting it this way, and then I think we're golden. This looks pretty good. So I've now backed into this station. Now I think it goes without saying this charger location isn't perfect. It's not ideal. The stations are angled, but we just want to make sure that they can get the units in. And I think even if you do have a charge port on the back passenger side, there's still enough access to walk through and to, you know, interface this with a back passenger side port. And of course, if you have a front passenger port like a Taycan, you would just back it in and pull it right here. So it's not ideal. I don't like, you know, the angled spaces. This is not a parking lot designed perfectly for DC fast charging, but I don't think the bollards are impacting our ability to get the cables around. And it certainly appears that it will protect the unit in case we have a rogue Prius coming through here or something and wants to take them out.
If we're going to do a bolt down bollard specifically instead of a cord bollard, we would prefer a cord bollard. They hold up better to a hard hit, but because of maintenance and being able to access these panels, we're going to do a bolt down bollard. That way they could be removed for maintenance in this unit because these doors swing open.
Right, so yeah, in order to get access, we have to pull these out. So, and we can bolt right into this concrete, right?
Correct.
Okay. Very cool. So yeah, I think this is good. It was my main concern, but it turns out to, I think, not be as big of an issue. I think the bigger issue is just the parking lot sizing and getting around this thing. But as a test unit for us and for some of the folks here, it's not really a public use charger entirely. I think it's just fine. Well, it is now the final day of installation. We're pulling the power modules out of the bay. That's what's going to be responsible for all the power going into the vehicles, and we're bringing it over to the front. Hell yeah. Guys, it is the final day of construction, and Alex is here all the way from New York and Jan from Austin from XCharge. And first of all, thank you guys for the charger.
We're stoked. We're stoked, of course. Yeah.
So we're going to do a lot more in the next video with you guys where we turn it on and charge for the first time. But we figured as part of the construction process, we should swap on a NACS cable. So can you walk us through roughly how that works? And also maybe just your rough impressions of installation. Obviously the permitting was brutal on this one.
Yeah, sometimes permitting can definitely cause some complications in getting things in on time, but it's the nature of the beast that we deal with. Rather deal with the permitting now than have to deal with something later or any surprises later. So at least as long as we get it stamped and we're good to go.
Yeah, absolutely. I love that they're drilling in the bollards right now.
You know how it is. Hey, construction site, live construction site.
That's right. They probably won't even hear it with these mics, to be honest.
Yeah.
So the unit is in a
pretty good spot. Fills up like one parking space, but it's a super long one.
Yep.
So we're going to be just fine here.
Yep.
And, you know, of course, I think we've been one of the few, as with you guys, pushing NACS. You were the first publicly installed NACS, you know, official J3400, whatever, you know, unit installed. And where did that go? Was that in LA?
That one was in LA. Yeah. So initially the NACS cable that we had was actually a lot thicker. It was just our own design that we had gone out and we'd made before actually any of the announcements came out about NACS being the new standard for many vehicles. We thought 70% of vehicles on the market are Teslas, or at least at the time were of electric vehicles were Teslas. So we're going to have to service those people. So we started deploying those last year, and all the while working with other suppliers to find our ideal NACS solution. Now have some really awesome cables that we're happy with, and you know, continue to evolve with.
Yeah, so let's check out that cable. You've actually got it branded with your name.
Ew.
So here we go, XCharge. It's got the weird looking end to it, which is like the 1,000 volt capable NACS.
Yep.
So a lot of them will have that, and you go up to 1,000 volts, of course, which requires, I guess, this type of non-shielding, but it should be good, easy to use, very almost Tesla style. Does the button actually work?
Yeah, button works. Button works.
Okay,
Yeah.
cool. That'll be neat. So we can open a charge port and have plug and charge.
Yep.
So that'll be sick. Yep. And yeah, it looks pretty long. Looks honestly not nearly as thick as even our other air-cooled CCS that's on there.
Yep. They're super light. They're super nice.
And this is 250 amps, boost to 300?
Yep, correct.
Okay.
250 amp boost to 300. So we're excited. Yeah, we'll get that in. It's a fairly simple, I think like an hour swap on this one. Yeah. Just really because of the cable positioning up top on the NZS, a little bit trickier. Other unit, the C6 is, we always say 15 minutes by yourself, 5 with a friend. I think we're a little ambitious saying it's generally about 15 minutes.
Yeah, but this one, okay, and we have to make a decision. Do we do the left side or the right side? And dude, I don't know. That's a tough decision because I pulled in here yesterday with a Tesla and I nosed in on the right side.
Yep.
And because you can get all the way up in the front of that space, you could just pull the cable back and plug it in, which this parking lot's not very conducive to making a U-turn to back in.
Yep.
And so I think most vehicles have with a NACS plug, our Tesla. And I mean, they're the only ones right now, except for Hyundai, which I don't think they started production yet.
But even if it's on the other side, it's actually fine because you can back in.
You could back in.
As long as you did the testing, we're going to verify this out of spec reviewed. It's been tested that the cable will fit.
Yeah.
Or it'll reach.
I feel like let's do the right side. Because I feel like most Tesla owners are just going to nose in,
pull in,
plug it in.
It's a nice change of pace for a Tesla owner to be able to nose into a spot instead of having to back up.
Right, you're just going to see them rip the front bumpers off every time.
So long as you tested the Cybertruck length, then we're definitely good to go.
As long as it's the same length as the CCS cable, it will reach all the way back to the Cybertruck charge port. And if not, the Cybertruck weighs enough we can push through the sign on the other side. So no, we should be good.
The bushes will take a beating, but so be it.
Cool. Yeah. So we'll swap on the NACS on the right side. CCS will be on the left, and let's rock and roll. Should be fun. Beautiful. Alex, so you and Jan have pulled out the initial CCS cable that came shipped on it. And dude, this thing is like significantly beefier with a lower amperage rating.
Yeah.
What's up with that?
It just kind of is the way that it is. You can see, I mean, the cable sizing is way smaller.
Yeah, and maybe this cable manufacturer decided their limits are within this range, but this will certainly be much easier for a driver to interface than that cable right there.
Definitely.
My understanding is we're going to keep this cable on hand just in case something happens and we need a quick hot swappable thing to get the charger back on.
Yep. Fingers crossed, and educational purposes too.
Yeah, it would be cool to show everyone what the heck a charging cable looks like, because this is kind of looks like an octopus here or something's going on.
Yeah,
pretty wild.
And often what we'll do is, you know, in instances that the cable is no longer good, this is obviously not that case because it's a new cable, but where they're not good, we have a recycling partner we generally will utilize, and goes for all the components of any of our units. Got a recycling partner that we kind of utilize for that.
Yeah, amazing, very cool. So yeah, basically it doesn't seem too difficult. You just wire it up into the charger. I'll overlay what it looks like up there where it interfaces, and we're gonna basically bolt this one on. You said an hour? I think 25, 30 minutes.
Jan's good. He's being conservative in his approach.
Yeah,
no, he's
that's
good.
a big juicy cable right there. Holy smokes. Well, glad to see that one go, and very much excited to get our XCharge NACS cable on this bad boy. So let's do it.
Absolutely.
Things are happening. We're getting the NACS cable.
You can see, yeah, I mean, the cable sizing is way smaller.
Yeah, and maybe
Yeah.
this cable manufacturer decided their limits are within this range,
Yep.
but this will certainly be much easier for a driver to interface than that cable
Definitely.
right there.
Definitely.
My understanding is we're going to keep this cable on hand just in case something happens and we need a quick hot swappable
Yep.
thing to get the charger back on.
Yep. Fingers crossed, and educational purposes too.
Yeah, it would be cool to show everyone what the heck a charging cable looks like, because this is kind of looks like an octopus here. Something's going on.
Yep.
Pretty wild.
And often what we'll do is, you know, in instances that the cable is no longer good, this is obviously not that case because it's a new cable, but where they're not good, we have a recycling partner we generally will utilize, and goes for all the components of any of our units. Got a recycling partner that we kind of utilize for that.
Yeah, amazing. Very cool. So, yeah, basically it doesn't seem too difficult. You just wire it up into the charger. I'll overlay what it looks like up there where it interfaces. And we're going to basically bolt this one on. You said an hour? I think 25, 30 minutes.
The end's good. He was being conservative in his approach. But
Yeah.
no, he's
That's
good.
a big juicy cable right there. Holy smokes. Well, glad to see that one go, and very much excited to get our XCharge NACS cable on this bad boy. So let's do it. Put in, you can already see just how nice that is. And then we have our grounding rod for the little transformer in the back that needs to be 10 feet underground. So that's going to get punched down through that way. And exciting stuff going on here. Bollards are in for the most part. They honestly look pretty good. And yeah, I'm loving this. This is sick. So we've got the NACS cable getting wired up there. And Alex, you were telling me that there's something unique about the NZS.
Yeah, definitely. So one of the cool things is actually that the wiring is all up top, as opposed to often with cables, you'll find that you need to go inside the unit, you need to go inside and change all the things. You can actually take care of most of the wiring up top. Obviously, you need access into the unit, and you need to be able to get up on top of it too. But yeah, it is it's kind of a unique feature of this one that keeps things tight and clean. Makes the change a little bit, I wouldn't necessarily say tough, but it just makes the change a little bit different than what you would when you're accessing through the front.
Right, but then you also actually get most of your cable length used for cable, because you don't have to come all the way down here to a connection point and lose your actual length. So we can get more room on this side, which is awesome.
It makes it a little more ergonomic when you're pulling it.
Yeah, totally. Yeah, much prefer this. So Jan is working on swapping out the holster to the NACS one from the CCS to match with the cable. He'll then connect up the cable management system, and we'll be good to go with the cable swap. Really not that bad at all. Didn't take much time there. Jordan, they just went to go plug in the charger to the building, wire it up hot.
Yep.
And you explain what happened.
Well, I was grabbing mics from the car, just walking through the building, and then I didn't realize there were people in the room over there, and then I heard a big bang, and some sparks were flying, and then someone said, "Oh," and then people were starting to run everywhere, and now the building is out of power, I think, and so is the lock.
Oh my gosh. Okay, we have no lights at the moment. Did we brick the whole building, Jordan?
Maybe, I don't know.
Oh no.
This around.
Yeah, we've got the emergency lights on now. Oh boy. Things are going well.
Yep.
So Jordan, they weren't even wiring up the charger. They were just preparing so that we could film. And they were just taking the faceplate off, and there must have been a loose wire or something, and that tripped the...
That's terrifying.
And so the guy's okay, thankfully.
Yeah.
That's scary.
Yeah. Wow.
Whoa.
It's dark in here though. You need an iPhone 16 for better low light performance.
Well, guys, we've made some progress throughout the day right now, and we're working on getting the power restored to the building. That was unintentional. But now we have to basically install the power modules in the charger as the final step. And because this is a battery integrated unit, we actually have two types of power modules.
We do.
A typical DC charger would just have AC grid power to DC to match the car. But because most of the energy going into the vehicle is actually going to be flown through the battery pack, we have mostly DC to DC with some AC to DC. So maybe you can walk everyone through that, how the power comes in, how everything works in here as well, for a little tour, Alex.
Definitely, absolutely. So right here we have our AC DC modules. These ones in particular are 22 kilowatt modules. They'll convert the energy coming in from the grid into DC, which then can either decide to charge the battery or go direct to a vehicle, depending on the state of charge of the battery or the internal rules that we want to follow for the charger. Most of the time, we're going to want to pull from the battery, just given wanting to reduce demand charges, have a higher speed charge based on what we could get from our grid connection. which is really the whole point of this unit, given that we replaced a couple L2 chargers to pull in this big boy. So what we'll do in a second here is we'll take these modules. We're going to start with the AC/DC modules. Those will go in the bottom here, as you can see the size difference. Inside of the charger is really built like a server rack. Everything's meant to be easy to slide out and slide in. When you look closer in there, you can see these pins on the backside. And so long as we connect up the modules to those pins, this is going to be the connection point that we need. Thinking of the architecture inside, there's a couple features that I think are really interesting to highlight. On the bottom down there, you can see that little pink thing, is actually a water ingress detection system. So it'll know if there's any water coming in, it'll trigger an alarm, shut down the whole unit, and make sure that you go and clear out that issue. Generally, have to replace a couple parts if that's going to be there, but ideally that's not going to be there. And we've gone through extensive testing in order to protect against any water coming into the unit. Up top, we have a smoke detector. In the rare occurrence that, say, a fuse blows and creates a small fire or any smoke, that'll go on, shut down all of the units. So these are all just onboard mechanics and onboard logic that we follow to make sure that there's not going to be an issue. When we think about the actual architecture of the unit, you have your screen here in the backside of that with an EMC protector to make sure that none of the waves or any of the effectively like the radio communications coming off of the electronics are going to interfere with the screen here and won't cause any issues. Everything here is really like the brains of the unit. All of your fuses, your protection, the DCB boards and the boards that we've manufactured at XCharge. You can see our logo up on there. So we take a lot of care into the actual logic that the units follow and all of the onboard mechanisms that are going in there. There's a few EMs as well, electromagnetic locks, that just are kind of various clicks and triggers that you'll hear when we first power on the unit for the first time. I guess going around into the back, aside from all the fuses and everything going on here.
Yeah, we're still active work zone.
Yep. And then I'm gonna have to get this bad boy opened. Going to the back, you can see where all of the modules connect in. Effectively, the power coming in and how that goes out to the unit itself. These are the don't touch it parts. Generally within the unit. Only in event of really serious changes that need to be made do we really want to ever go past this plastic shielding here. And then the main annual item that you're going to have on any of the actual replacements come from the filter cleaning within the charger. So there's a filter that's slid in on the back side here. And that would be kind of your main service item on the NZS for any of the annual filter changes that go on
so
there.
the battery pack, it's LFP.
Correct.
And so that should be pretty hard wearing, pretty hardy. I think it was shipped at around 25, 26% state of charge, it said on the box.
Yep.
Which is perfect for long-term storage. It's the best way to reduce degradation.
Exactly.
And are we able to set it to not charge to 100% every time? Or do you want it to charge to 100? Or what do you think?
Yeah, we can set it to. Honestly, what we found in the field is the degradation on the battery is like pretty limited unless you're really going through a lot of charge and discharge, which here we might see a little bit more of the charge and discharge just given the out of spec needs. But all things considered, we're pretty confident that keeping it and going up to 100 is not going to be too much of an issue from the long-term use of it.
It'll help balance the cells too, being LFP. They probably need to see 100 every once in a while. But so the power here, so this is where all the power comes into the unit, right?
Correct. Yep. And that's where it wires up into. Actually, these are the DC-DC connections, and then your power is actually going through into here and then making the decision from the AC-DC modules whether that's coming over into your battery unit, or whether that logic is going to carry through and go direct into the car, just based on your internal rulings, what you said on the back end.
So it's 233 kilowatt hour gross, 208 usable as stated. So you do have some buffers in there, of course. So maybe we really shouldn't worry about using the hell out of it.
No, we definitely want to put it to the use, right? I think we're very confident in the life of these batteries and how that'll carry through. So I think definitely charging it up to 100 and discharging it day in and day out is not going to be a problem.
Yeah, I mean, it's really just going to be weekends when this thing is kind of sitting, but even then we're going to cycle it. So
I don't know. Recycling,
I mean, it's just, it's going to be used hard, of course. So yeah, I mean, I think to put a power module in, it seems pretty easy. You just slide it in the rack, right? And then a couple screws. Is that how that works?
Yeah, the hardest thing is that you're just going to need to have a little bit of muscle to make sure that you can lift those bad boys. Again, and I were talking yesterday, it's about 40 pounds on some of those modules. So yeah, it's not not easy work, but it's not also really too laborious.
Yeah, nice. And then what's behind these panels? I know they're on right now. This is our battery indicator lamp. So in a wrap, we're thinking maybe we'll just put like a little battery logo around that or something. Yep. What's in this area?
Yeah, so this can open up for access in the event that you need to come into the front end and modify anything. Generally, we don't really have to open up this front area. Most of the servicing, most of all the connection points are in the back end of the unit. This just gets opened up when we need to access the cells directly.
Okay.
And do any work on that.
Very cool. And I'm just noticing now as well, we even have a NACS faceplate here, which is awesome.
We do. Yeah, we put that bad boy in. That's XCharge engineered.
Yeah, there you go. Love it. Well, cool. Let's get the power modules in. Hopefully they get the building powered up. And then we can actually turn this damn thing on.
Yeah.
Months and months and months of planning and excitement waiting for later today. I really can't wait.
Me too.
Nice and easy like a glove.
Yeah, one power module. That's the first one. And Jan, this is the AC to DC. So all of the power from the grid is going to come in through those two bottom ones. Okay, cool. That's really all it is. So yeah, and correct me if I'm wrong, but each power module has a specific place to go in line so it understands its job.
Yes, it is.
And it's, you can tell it where it is, because these are actually, shout out to our sponsor InfyPower. These are their modules, which is sick. You can set the dip switch to show the position, right?
Yes, it is. And each position will be recognized by the software, and then so the software can to work with the module, like to control which module get into the work or not.
Yeah, exactly. So we're going to set this one for position 4.
Yes.
And then that one will be position 5. And everyone can see here we have position, basically, you know, these dip switches correspond with whatever mode they're in. But right, so this is number 1, 2, 3. Then we're going to go 4 and 5. And again, these are the DC to DC converters, or buck boost converters. And then these are the AC to DC rectifiers down here. And once those are all in, then we can actually power it on, because I think the power to the building situation has been sorted, which is great. And we're ready to freaking motor through. This is wild. And this is really easy. So if ever one of these, you know, DC to DC converters fails, or anything from the AC to DC rectifying side, you just swap in a new one.
Yep. Like a server rack.
Yeah. I mean, 5 minutes. That's amazing.
Yep.
Dude, you're getting suited up. Crazy. So the charger's pretty much done, guys. But we cannot shut down the building because we have crazy experiments and stuff running. So we're going to live connect the charger. So yeah, so Josh is wearing like a high voltage suit. We have a broom that the guys can push him off in case he gets electrically connected to a hot line.
Hung up, as they call it.
Hung up, yeah. And this is not the preferred way to install things, but we just have so much sensitive equipment. We already cut the power once today by accident. Yep. So they don't want us doing that anymore. Yep. Not that we have anything to do with it.
It wasn't intentional.
Yeah. They just had, like, when they were unscrewing something in the panel, it hit a live thing and arced, and breaker did its job. Yep. So now basically here comes the rest of the crew, and we're about to wire this thing in. We're going to watch from here behind the glass, but Josh is suited up, and they're about to connect it all. So let's freaking do this. All right, so he's going in hardcore to connect up 480 hot. Fully suited. Here we go. So cool. All right, so I think that's the high voltage connection.
Okay.
No one died. Thank God. For Halloween, we should just dress up as that.
Yep.
Be like, drive electric cars, need to wear all the suits.
Yeah, you going up to a level 2 charger in that suit, just
Yes.
trying to plug in your lead.
That'd be amazing. All right, we've got it, I think, installed. Woohoo! Well, congratulations on not dying.
Yeah.
Found it. Hell yeah. And
Let's back up.
then we've got our breaker right there. So can we flip it on?
Yeah, let me put the dead front back on and close up the panel. That way it's safe.
Yeah, yeah.
And then we'll turn it on.
Holy smokes, that's gonna be epic. All right, so everything's now buttoned back up. Which one's our breaker here?
It's going to be 10, 12, and 14.
Mm-hmm.
This 50 amp breaker here.
Cool. So we should get about 20 kilowatts usable is what I've calculated, because we'll do 40 amps at 480.
Yeah.
And so that's what's just gonna be running flat out forever, basically.
Nice.
So that thing's gonna be working hard for the rest of its life. Thank you so much for doing that.
Labeled an XCharge.
Okay.
In case y'all need to come in here and cycle the power or anything, but you should be able to do it from the disconnect if you need to.
Very cool. That's awesome.
All right.
So now that we've got the power hooked up inside, we're gonna flip the breaker on. Austin, you have the pleasure of doing it. Hell yes. So now we have power running to the unit. Oh boy. Fans are spinning. Things are happening. Yep, gotta flip some stuff in the back of the charger, but it's energized for the first time. That's awesome. So we're gonna override the door sensor temporarily, which is not something you really should do, but that will clear the alarm failure. We have the front door and the back door open right now. So we're wide open. And then we'll be able to see a bunch of stuff. So it says battery disabled. The transformer's not powered up at the moment, but we're working on that. And dude, first time we get to see the screen.
Wow, that's meaningful.
Yeah.
All day.
Oh yeah, love to see that. So please use another charger. I like how they decided to capitalize charger, but not use another. And back is all caps.
YouTube title failed.
Yeah, that's not how we title YouTube videos. Every word requires a capital.
Update
And there we go.
icons later.
Yeah, so we'll update the icons in a bit.
Yeah.
Hell yeah, that's awesome. So yeah, can we put a NACS icon on this side?
Yeah, we can do it later.
Oh, great. So we're going to update everything tonight and everything like that. Is there a way to see at what state of charge the battery's at?
Yeah.
So we
It will
hold
show
down.
you the
Yeah.
battery.
But so it's not connected yet.
Yeah.
So they are not talking to each other. But, oh, dude, that's cool. So that's not the password that will always be
Yeah,
there.
we can change it later.
Yeah, we're going to
And
put a different
then-
one on.
We can do the SN configuration later,
Yep.
and we can do the hard reset.
Soft reset. Oh, so this is all
And we
awesome
can also
stuff.
change the charging models
Right.
direct on here.
Yeah, so we're going to leave it in max initially.
Mhm.
And is there any benefit to putting it in eco? Maybe less battery wear?
Yes.
Yeah,
Yes.
but max full send.
Mhm.
We like full charging speed. And this is where we can kind of set pricing.
Yeah.
Okay.
can
Or
do
this
it
is to
on-
look at pricing. You set it on the back end.
Yeah.
Cool. Check this out. That's snappy, actually.
Yeah.
So this is our AC connection. We haven't told it that we're not at max power yet.
Mhm.
And then you push and hold here, and that's where it will tell you.
I'll show air conditions. The conditions.
Damn, this is so cool. Love it. All right, well, can't wait till we get the battery talking to this thing, and then we can see the state of charge. That's the one thing I'm really curious about knowing. So I think the next issue is we've got too much voltage into the transformer. You can see we've maxed it out right there, and we're coming down here, and it's supposed to be 277 on the primary and 220 on the secondary side, but we are well over 300. So we got to dial that down a little bit, somehow figure that out, and then we're good. So we're opening up the front of the unit right now. This is really the first time we're able to see the actual LFP sales, the LFP cells in here, and looking pretty cool, actually. That's awesome. And you know, another idea for a wrap could be like a X-ray thing, like G's doing with the Cybertruck.
Yeah, wow.
So that could be cool, but I think we have something cooler in mind. And we're going to install a couple bus bars to link the different sections of the battery pack together, and then we can flip the battery on and rip. So transformer wiring issue has been fixed. Power is now on. Did you flip the battery on, or is it still off?
Battery's still on.
Okay.
We're gonna verify voltage at the transformer.
Okay, got to make sure that's all good.
Yeah.
And then, yeah, then this thing's going to boot up. There it goes. XCharge. Yeah, epic. So now we've got the correct secondary side and the correct... Dude, you're a genius. You had to rewire that whole thing. Freaking epic.
And we're good. Now that the transformer is good, which mostly feeds the HVAC system, right guys?
Yes.
Okay, so now we can actually turn the battery on, right? First time in really ever, we're turning the battery on this unit, so.
Okay. That's the main switch.
Damn, brother.
Meters. And there's the power.
Okay,
Great.
power switch in there. Yeah. Oh, nice. Yeah, we've got a light. Hey, it's got state of charge, if assuming that was the charge indication.
And then we got turn on the battery from here.
Okay. Yeah.
Yeah, there is out.
25. So it didn't lose anything because it was shipped at 26. And it's at 25%.
See state of charge light.
Yeah, state of charge light. Oh, this is so cool.
And then we need to do the.
Oh, but isn't it going to try and pull 44 kilowatts? We got to tell it can only do.
Yeah, before we charge on it.
Yeah.
And then we got to do it by my laptop.
Yeah, laptop set.
Okay,
Yep,
cool.
yep.
Nice. But that's awesome. I'm glad.
Also, this charger right now is connected with the backend already.
Already sick. That must mean Nelson set up correctly. So, Yen, I think it's on his. It must be on his dash.
Yeah,
That we
I got it
created.
already.
You already logged in. All right, cool.
So now really the next step, just to finish off this video, is to update the firmware. We're going to put the newest software on the charger. We're going to get the battery charging. And then in the next video, guys, we're actually going to charge a car. But for now, Jordan has brought over some pizza. Finally, yeah, the pizza took a little while. Transformer is all solved now, Jordan.
Oh my gosh.
Look at this thing, powered up. It's got a little battery status indicator over there.
Heck yeah.
It only lost 1% since it was packaged up.
What did they package it with?
26, it's at 25. It's
Nice.
perfect for storage.
Yep.
It's LFP, but even LFP likes to be low.
Yep.
And we're going to set this thing, you know, before we start charging, we basically need to tell it, hey, don't take more than 20 kilowatts from the grid.
Yep.
We're going to set it for, you know, basically 40 amps, 19.2 kilowatts
Yep.
is what the constant feed will be into this. And dude, I'm so freaking pumped
Ready to charge.
for the pizza. And I can't wait. Can't wait to charge. Dude, we got some serious pizza here. Okay. What's with the mushroom?
One has.
Oh, other stuff?
One's not. Yeah.
Okay, I don't want any of that stuff. Yeah, that's too exotic from.
Yeah.
Yeah. All right. Well, thanks so much for watching the construction video on the XCharge. Next video will be all about setting up the software, dialing in, learning about its limitations, and getting it charging. So shout out to these guys for flying all the way out here and spending many hours helping us set it up, and really just epic. It's great. So. And pizza. Oh yeah, car just kicked on. Awesome. We are charging. High five. Epic. Epic. Thank you all so much. And we'll get a boost of about 10 minutes at a little bit higher power with this cable.
And they're both getting the full amount.
Yeah, they're both chugging. I just don't understand why this only says 78 kilowatts.
Out.